In this part of the linear graph, we got two types of travel graph. So the first type is what we'll call distant time graph. So the idea of distant time graph will be you are plotting distance against time. So time is always on the horizontal axis and then distance is on the vertical axis. So in every case, right, you need to take note of the units for the time and the units for the distance. Okay, so there's one main feature of the graph, of such a graph. So if you detect that there is a distant time graph, the main feature will be the gradient. So there is an implication on gradient. So the gradient represent speed. Okay, so that is the main feature of a distant time graph. Okay, so then let's talk about how do we read a distant time graph. Okay, so if you look at these 2 points, so if you look at point number 3 and number 4, in a distant time graph, if you got a straight line, whether it's a positive gradient or negative gradient, it just means that the particle or the person is traveling at a constant speed. So when we say constant speed, right, that means it's like it doesn't go fast or it doesn't go slow. So they maintain a certain speed. Okay, so for example, if you are walking to school, so you maintain a proper speed. You didn't like make it faster or slower. Okay, in a distant time graph, if you see a horizontal line, it actually represents zero speed. So a horizontal line has zero gradient. So the gradient is zero. That's why the speed is zero. Okay, so when the speed is zero, right, there's no speed at all. You're not moving at all. So it's considered at rest and stationary. So actually we can kind of summarize in a very simple diagram. So usually, right, from a distant time graph, we can tell the distance between two locations. So it can be something like B and then this is A. So it's something like this is town A and then this is town B. Okay, so in between you will have the reading that you can read of the distance. Okay, so we can tell the distance between two locations. And when we have positive gradient, right? So for example, I started something like this, and then like this, then I'll continue. Okay, so for this person, right? Maybe this person X, right, starts from A, and this person is going to B. Okay, so you can read off the distance if they provide you with the data. Okay, so how does this person X, right, start from A? So he starts from rest, and then he's a uniform speed. Okay, maybe there are some amount of time, and then after a while, maybe it's a bit tired. So this is the resting part. After some rest, then you continue to go and reach town B. Okay, so these two sections are the part that's positive gradient. So when do we get negative gradient? We get negative gradient, for example, if another person Y starts from town B. So maybe starts from town B and then it go direct to town A. So this is the person Y. So if you realize that this part is a negative gradient, that's because it's opposite direction. Okay, so and for this person Y, you don't see any horizontal line. That means it doesn't take a rest. Okay, and in this situation, right, these two person actually starts from the same time, but sometimes they may not start from the same time. Okay, so later on there are some examples that shows that they doesn't start at the same time. Okay, so because they are starting from opposite direction, so there will be a meeting point. So this is the point where they meet. Okay, because they start from opposite direction. For Y, right, it starts from B and it is going to A. So from here, then we know that they will actually meet each other. So the intersection is the time that they meet and the location where it meets. They may not meet halfway. They may meet a certain distance from town A, meet a certain distance from town B. Okay, so then once you understand a little bit more on this, right, then how do we calculate gradient? So you can use the usual gradient formula, the one that you are used to. You can use the coordinate formula, but you must formulate the coordinate, or you can take the vertical distance over a horizontal distance. So vertical distance over horizontal distance. So it'll be something like, so if I would like to know this gradient, I can take the vertical distance over the horizontal distance. Okay, so that's how we can find the gradient. Okay, so that is the idea of gradient of a straight line on a distant time graph. Okay, but sometimes our distant time graph may not be a straight line. It can be a curve. So in this situation, if I have a curve, and how do I measure the gradient? So if I have a curve like this, so can you see this part here is a curve? And let's say I'd like to find the speed at 5. So I got to draw a tangent here. And then I got to get 2 points. And then I calculate my gradient. So you only need to do that when you have a curve, but it doesn't happen so often. Okay, so these are the main feature and the main understanding. And then, of course, we always have the average speed. Average speed is like your primary school idea. It's the total distance divided by the total time. And it is the same idea in primary school. The total time also include rest time. So it include the resting time. That means if there is a horizontal line which indicate rest, right, you also include that time. Okay, so I think all this will be easier illustrate if we talk about practice question 1 and practice question 2. So if you read this question, so a man left his house at 11 o'clock. So where is 11 o'clock? So 11 o'clock is actually here. And then this one is like 10 minutes after 11 o'clock, 20 minutes after 11 o'clock, 30 minutes after 11 o'clock. So by the time you hit 60 minutes after 11 o'clock, that means this one is like 12 noon. So you got to interpret and read the question. So this person left his home. That means this part is the home. So left his home to pick his son from the school. So on this part, I detect there's a horizontal line. That means this is the resting. So I'm guessing, right, this part is the school. So at the school, he has to wait to pick up his son. Then now he's coming back on the way home. So on the way home, he stopped to refill his petrol. And then there is a horizontal line. I'm guessing this is where he rests at the petrol. He's not moving at the petrol. So I'm guessing the petrol kiosk is here. And then he will make his way home. So the whole journey take him 1 hour. Okay, so that's the interpretation first. So you can have an idea. He's going to school, from home to school first. Then he paused at the school. And then from school to the kiosk. So after the school to the kiosk, he rests. And then from the kiosk, then he go home. So you should be able to visualize the journey in a distant time graph. Okay, then we carry on to answer the question. For the first part, what was his speed on the way home? So the speed on the way home, which is like the gradient. So you can take the vertical distance over the horizontal distance. So the vertical distance represents the distance. So if you look at the horizontal distance, the vertical distance, this is 10 kilometer. Then the horizontal distance represents 15 minutes. So if you do it in minutes, if you do it in minutes, it will be kilometer per minute. Okay, there's something wrong with the answer. Okay, or if you have done it in um, hours, it will be 15 over 60 hour. So it depends on the unit. Unless it's specified by the question, then you will have 40 kilometer per hour. So in this question, they didn't specify, so it's really up to you. So you need to take note. So at what time did he leave the school? So you can read off from here. He left the school at 30 minutes after 11 o'clock. So how long was he at the petrol kiosk? That means how long did he stay at the petrol kiosk? So if you look, he stayed like 15 minutes at the petrol kiosk. And then what was the speed on the way home from the petrol station? So again, that is a gradient idea. So you take the vertical distance over the horizontal distance. So the vertical distance is 6 kilometer. Okay, again, it depends on whether you want to use 10 minutes or you want to use 10 over 60 hour. Okay, so if we use 10 minutes, then our answer will be 0.6 kilometer per minute. Or it can be 6 kilometer over 10 over 60 hour. You got to be very mindful about your units. So that is 36 kilometer per hour. Okay, then what is the average speed for the whole journey? So if we're talking about the whole journey, okay, remember we are talking about the total distance divided by the total time. So the total distance is 20 kilometer because it's from home to school, which is 10, and then he traveled back, that's another 10. So it will be 10 kilometer, but it's a to and fro journey. So it's 10 kilometers times 2. And it takes 60 minutes. So again, if you are doing it in minutes, right, then you got 1/3 kilometer per minute. Or if you have done it in hours, the whole journey take 1 hour, then that will be 20 kilometers per hour. So that depends on what the question is asking. If the question didn't state, then it's up to you, but you make sure you state whatever your answer units is. So for not giving units, you might get penalized, and it's quite easily to get yourself confused. So this one is a single journey. It's like a person going to and fro. In the next example, we got two drivers and they are from the opposite direction. So you can do a little bit of interpretation first. So for example, we talk about John. John starts from A. He traveled all the way to B without stopping. After he hits B, then he rested. And then he returned back again. So John makes a to and fro journey. So for John, right, so A to B, then back to A. Okay, but there's another driver, Alvin. Alvin came from the opposite direction. And they started at the same time because they started at 11:30. And then for Alvin, right, he take a short rest and he continued. So for Alvin, his journey is only B to A. So make sure you read. So if I want the average speed for John, I need to get the total distance. So because he make a to and fro journey, that means his total distance will be 40 kilometers times 2. And all together, he take 1 hour. So that is 80 kilometers per hour. Okay, so because they are traveling from different direction, okay, so later on there will be a certain point where they meet. Okay, before we realize that, okay, we talk about part B. Part B, when and where Alvin stops. So when, so Alvin stopped here. Okay, so you can look at the horizontal line. So this is the part where Alvin stopped. Because it's a horizontal line. Okay, so when? So at what time? He stopped at 11:45. And where? Where did he stop? He stopped at 11:45 at 20 kilometers from B. He started from B. Okay, or because happened that this is the same point. Either you mention is it from A or is it from B. It doesn't matter whether you mention how far is it from A or B. You just have to state a reference point. Okay, and for how long? The duration is 5 minutes. Okay. And then the last part, okay, when and where John and Alvin pass each other. So I got to look for the intersection point. So I think it is at 11:42. Okay, you can count one square represent how many minutes. So at 11:42, they pass each other. Okay, where is the location? Is your choice. How you're going to describe the location? You can describe like this. Okay, either way, 25 kilometer from A, or it's actually 15 kilometer from B. Okay, maybe I got to erase my line, then you can read. Okay, I think the answer is 24, so it's around there. Okay, so you need to have a reference point. So if your reference point is different, of course the number can be different. But if you never put any reference point, right, you are not going to get any marks. Because if you put a 25 kilometer, I wouldn't know. Is it 25 kilometer from A or 25 kilometer from B? That would be a different location. Or you just put a 15 kilometer and you never tell me that it's the 15 kilometer from B. I also won't know where is the location. So when you want to tell people location, there must be a reference point, or else you will get marks deducted. Okay. So that's the idea of a distant graph.